Okay. Uh, Welcome to today's class. I think yesterday we saw so far we have been doing some fundamentals when it comes to science, introduction to pandas for data analysis, and at this particular stage now we want to make progress, and our objective now is to be able to look into data cleaning. This is one of the most important topics to understand as data science is concerned. So I see some persons are not yet there, but having a proper understanding of this is needful. Now, that's it. Do we have any challenge so far based on what we have seen? We can look at it before we make progress. Oh, everything is thus far very good. Any challenge?
So far, so good, sir.
Okay, that's nice. Okay, so nice to listen.
My God, no military army. What the heck? I just think she was the level of the I think that's what he said they go on. I don't know it a fish bar. The woman out there. One
So the first thing we want to underscore is that real world data is rarely clean. Yes, no, you hardly get data that is ready for analysis. And so what a professional data scientist does, or a professional data scientist does not complain that the data given is dirty. You basically try to diagnose why we have the dirty data, or what causes the data to be dirty, have a proper understanding, document the issues you find, and how to clean the data in an acceptable approach. So basically, you must take some time to understand the data, to clean it, and to make the data ready. So, what is data cleaning? What is data cleaning? Now, by definition, we can define data cleaning as the process of identifying. So the first thing is that you have to identify. Identifying, we have to identify, correcting. The first you identify, you correct, you transform, and also handle appropriately inaccurate transform, or and or let's say and, because those things can all happen. Handle appropriately, incorrect, incomplete, inconsistent, 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 and or duplicated data. So, in other words, or put simply, when we talk about data science or data cleaning, we are looking at the process where the data scientist will start by identifying issues with the data. You correct the issues. The correction could mean transforming the data. For instance, I want to analyze data, and the data given to me contains days, weeks, months, and the rest, and I'm interested only in months. So you may need to transform, or yes, you may need to transform from days to weeks to months, and vice versa. In some cases, the data may be inaccurate, which means there are issues that maybe you ask someone to give the person's gender, and the person wrote but something else, which is not part of what we are expecting. In some cases, there's inconsistency, which we'll see how that can be manifested. In some cases, there could be duplicates. One thing appears multiple times in the data set. For instance, a transaction is recorded multiple times by a user. Now, it appears multiple times. That transaction is not valid and cannot be used as such. So, in other words, given real-world data, a typical data set may contain 1, missing values, 2, duplicates, for instance, maybe duplicate records I've just explained, may have incorrect data type, Something is a figure, but because it was written in quotation marks, it appeared as string. That's incorrect. In some cases, we may have even spelling inconsistency. For instance, instead of spelling male like this, you spell it like this, or maybe other ways. Yeah. While the spelling might all be correct, but they're inconsistent, and data we provide will not be accurate if we go ahead and analyze it with such differences in spellings of the same word. It's because Python in particular is quite sensitive when it comes to some of these things that we're explaining. Another thing that we may face, apart from inconsistency, will be outliers. When your data outliers are extreme values. In a class where everybody's scoring around 10, 12, 13, say somebody with 20 on 20, and there's another person with 1 on 20. These are called extreme or outlier because they are far away from the real data set. Then we may have invalid cases. Invalid cases. It's not uncommon for you to get to a point and you see, maybe, for instance, you're dealing with Excel. When there is a formula error, they'll give you a kind of strange figure or strange sign and things like that. That is invalid cases. In some cases, you may have extra spaces. Instead of writing, again, mail, like this, you put space before you write. You may not see it with your physical eyes, but it will pose a problem for analysis and may need to be looked into. In other situations, we may have incorrect capitalization. Again, some of these things are similar. For instance, we may have a situational capitalization. Please give me a second. So, when you have dates that are not, for instance, some start in Cameroon, you say maybe the day, the month, and the year. You may have another one starts with the month, the day, and the year. Or some are using slides, some are using space and things like that to write. So such type of situations may pose an issue when you are analyzing. Then another data cleaning issue to take note will be incorrect numeric values. Incorrect numerical values. For instance, when we have yes as 1 and no as 2. Now, this may seem as they are figures, but they are not true figures. They're just annotations. Or in some cases, we have things like this special character. Some special characters and things. Yeah, so we'll need to take care of. Then you may also have a situation of too much column, unnecessary columns. Unnecessary columns. When there are so many columns in the data set, you have a data of 50 columns, and you want to analyze just about 5 or 10. So you need to clean. Most of what we have said, if you go back from when we started using Python you'll discover that we have treated some of these issues. But we were not applying them to data. For instance, what happens when you have incorrect capitalization? You see that you can say maybe upper, this lower, and so on. We'll normalize it. We talk about left strip, right strip, and so on to take care of spaces. And so those are some of the issues that we'll be looking at and how to apply them to our data. But the important part another thing you may find is mixed data format. Yes, mixed data format. Data format. For instance, we have 25 francs. Now, this is a figure attached with strings to it. You cannot analyze like this. You cannot go ahead and analyze data in this way because it will not give you accurate results. You'll be treating strings as figures, which is very wrong. So, in sum, what we are expected to behold as this particular lecture is concerned and to understand as this particular class is concerned is that Data cleaning is very, very important. And so you do not just randomly clean data. You don't start just changing values. You use a systematic approach to go through this process. There is a systematic way that helps us. And starting from raw data, the first thing is for you to understand the data. You have to understand the data. Have a proper understanding of the data. The second thing, understand the data. The second thing will be to have an understanding, profile the data. We'll discuss more about profiling of the data. Profiling the data is like part of the trying to know what type of variables are then categorical, continuous, is the data longitudinal or cross-sectional, and many related issues. Then the next thing is to identify potential issues. When you profile the data, you identify potential quality issues or quality problems. There are quality problems in the data. That's when you now have the ability to identify that we have missing data, the ability to be able to see that we have outliers. Now, when you identify that there are quality issues, you have to investigate the problems. Yes, investigate deeper. Now, I've discovered that there's missing data. You don't just start analyzing, you investigate the problems. Investigating now helps us to have a more comprehensive ideology or way to manage the data. You now have a more comprehensive way to manage the data. That comes after you investigate. Now, when you do the investigation, the next best idea is to decide how to handle the issues. How do you handle these issues? So let's say this is issue 1, understand the data. Issue 2 is for you to profile the data. Issue number 3. Issue number 3 is to identify the problems. What's in your... Hello? I'm in class, please. Yeah, have you sent me a message? Send a text, I'll look at it and revert if I can. Tingon Ferdinand, I'll text it. So, identify. Then the next thing to do will be to, which is the setting is to do what? To clean / transform. That depends on the issue you have. And then you can document what you have done. It's always good to document the steps you have taken. So you can say maybe document. That should be kind of the 7th item. Document. Now, the reason for documentation is to have a proper understanding, and that even tomorrow they bring back the same data, you should be able to clean it using the same approach, because if you adopt different approaches, you will have different results, which is highly probable. So, you should be able to clean and document. And then the last thing will be for you to save the data for analysis. You have to save the clean data for analysis. Save data for analysis. So, what are we saying? In order for you to have a proper understanding or to go through the data and resolve issues, you have to start first knowing what to look for. Am I looking for one, missing data, two, whether there are duplicates, three, incorrect data types, four, inconsistency in the data type, five will be outliers, extreme values are different. Six will be invalid values. Seven should be about extra spaces where they're not supposed to be. Eight will be incorrect capitalization. You might not seem as a problem, but it's a problem because Python is case sensitive. Then we have, I think 8 or 9, impossible dates that are wrong or dates that might not be. And so maybe using software has a way of capturing the date. But that's not how you use the data, and that will be a problem. Then we have incorrect numerical values. Values that are written, for instance, we just get the case of 25 francs added to it. Just addition of francs will affect the numerical on the train of that, and we need to separate text from the rest of the data. Now you have to maybe look for whether there are missing columns or unnecessary columns and remove them, and so on and so forth. So that is why you need to have in mind when you are engaging into data cleaning. Now, having said that, the next thing is to understand what to do when it comes to the cleaning process proper. The first thing is to have a proper understanding of the data. That's where you see that we say df.head, df.shape, df.info, df. That's how giving you an overview of your data. Now you're trying to understand the data, you're trying to profile the data to see what is and what is not, which a relationship exists between which and which, if that will be a concern. Why do we have some values missing and why not? And that goes to identify the quality problems. What are the quality problems in terms of missing, duplicates, incomplete data, inconsistency, outliers, invalids? You must be able to identify quality issues. So this act as the list of quality issues to be conscious of. And this is how you go about now resolving the issues in real time. Any question? Okay, I think that there's no question. Let's make progress. Now, like any other task, we often start with importing our data. We start by import data. Import data. Again, look for more ways how to import your data. And I can go for the easy way that we already know is df. But before that, before importing data, let me import my libraries. Since this is a new session, let me not assume. So I have to import. Please give me water. And that's this. Import NumPy as this. Import Seaborn as SNS. We run this. The next now will be to import our data, which say, let's call it again df. Should be. Let's see if you use this pdf.read underscore CSV. Titanic. Let me see if this works now. This will not work, probably because it's not the right spellings. It doesn't still work, so let's use just our SNS. So SNS.load underscore dataset, and the name of the dataset is Titanic. Please, can you hear me water? Yes, I'm getting it. So we have our data loaded. Now, the approach says understand the data. Understand the data. And to understand the data, we also start by inspecting. So we say df.head. We have already seen this data, so might not be doing much again. Maybe df.tail or df.shape, which gives us the number of columns, the number of rows. We may want to see the column names, df.columns. We can have all the columns that are available. We may have df.info. Log.info. Log.info. And it will give us this. These are like primary codes that you run to see what is happening with the data. So it's very important for you to run this code. That's basically understanding the data or trying to get hold of the data. Apart from this, we also have to say df.describe. Df.describe will give us all the descriptive attributes of the data. I can as well say df.describe, and I say okay, includes equals to all. So they will run descriptive data for us, including every aspect. Now, this is basically part of data understanding. Data understanding. What my interest here? To see the mean, the median, and the standard deviation of all the continuous data. To solve the interest here, to be able to see the frequencies and the unique categories of each variable, and so on and so forth. So that is very, very useful for us to be able to get that. Now, when I'm done with that, we can now move on to checking the data type, which is part of what we're expected to do. And we can say df.dtypes. Dtypes. So data types will give us details of the data, whether we're dealing with integers, class, float, and the rest. So that helps us to understand the data. I might just learn some. Now, why are we interested in this data type? If we don't run the data type, suppose we have age equals to, just say, quotes open 45. Maybe 45. Although this may seem as a figure, it's not a figure. You may see it as a figure, but it's string. It's string, and so it's treated as text. So the best way for us to do is to check the data type. To check the data type, to have a proper understanding of that data type. So pandas will not be able to manage numerical data that is found in the form of strings. Pandas cannot manage that. In which case, you either see us trying to transform the data or maybe remove it completely from the data if the variable is not of prime importance. That is the first thing. Please just give me a second again. Others have not joined the class today. What's the issue? So we must convert a data format that is wrong to the right data type. The next thing you may want to check with the data is missing data. Missing data. Yes. Missing data. Missing data. And this is very, very important. Yes, the concept of missing data is very, very important. Now, when we talk about missing data, we are referring to situations where some aspect of the data were not provided. When they were not provided, and so we are faced with, why did this person not give? For instance, you send out a questionnaire, and the questionnaire goes, some people answer the first page and ignore the rest. That forms missing data, what they did not. The different questions. So you need to identify why they did not answer. Now, not all missing data is a problem. Not all missing data is a problem. That's why it's important for you to have an understanding of why there is missing data even before you engage in resolving it. If we don't have an understanding of why there is missing data, and you engage into just handling it, it will be a problem. Now, missing data occurs when some values are identified not to be available, whether when they were not recorded or also not usable. Take for instance, I have age, I have fair, and I have sex. So under age, I see something like this. Under fair, I have 250 or this. Under gender, I have male. That is for, let me say, passenger. So let's call this one passenger 1. We have passenger 2. The person's age is 22. Person's fare is $100. Person's gender is male. Oh no. Male. So passenger 3, we have age, and the person has given, and we go to fare. The place is empty, and here we have something like 2. Now, here, this is missing data, and this is missing data. That's why I say NNN stands for missing data in Python. But it's not enough for us to just clean this data any way we want to. We have to ask the question, why is it missing? Why is it missing? Now, when we ask the question, why do we have missing data with respect to this particular variable, and we're trying to analyze it, is because the reason why it's missing helps us to know how to treat that particular thing. And we have what we call missing data. Is not something that you just go and say, okay, because this one is missing, I'll remove it. No. In some cases, we have what we call true missing. Yes, true missing or truly missing. Truly missing. Now, what do you mean by truly missing? Truly missing is when actually the participant or that case never provided that response. We simply don't know the age of this passenger. That is truly missing because we don't know the age of the passenger. But then there are some situations where the missing might be because of another reason. Yes. Let's say we say that here it is, let's call it not applicable. Not applicable. Let me add another thing here. Let's say the fit person, the age here is 0.4. And here we have fare. The fare here is NAA, or let's say NPA, and gender is, let's say, female. Now, what happens is that if you study this situation, you discover that not applicable. For instance, here, if this was a child of 4 months, children don't pay for they don't pay the fare. You want to take a child from here to Yaoundé, the child will not pay. So the reason why there is missing data here is different from why there's missing data here. This person is truly missing because we don't know the person's age. But here, it's not truly missing. It's a kind of not applicable because the question or what we're trying to get doesn't really relate or concern these persons. Another example, you are a student and you go to school and they ask you, do you have a father? You can either say yes or no. If you say no, the next question that's supposed to say, what is your father's name? You automatically, that particular question is not applicable to you because you don't have a father. So that's not truly missing. It's not applicable situation, or we can call it missing by design. Or another similar situation to help us understand. Let's say you're dealing with your interviewing persons. You ask, do you have a car? The person say yes. So you can ask which car type or which car model. It can be Toyota, it can be Mercedes, it can be whatever. But if you ask somebody, the person says, no, I don't have a car. You don't expect the person to be able to answer that question, the car type. So the situation of not applicable means it's not necessarily as missing, but we can consider it as missing by design. It's not applicable because she doesn't have a car and will not be able to give a particular a response to that particular question. So we cannot solve the problem of this missing data by just replacing it with a kind of unknown, because there is a reason why that person hasn't provided that information. So we cannot just say that, no, let's replace it with unknown. That will be making a big error as this thing is concerned. Is it just data for this thing or complete data? This seems to be just equity registration. What about the other transaction? They're in separate files. So now, the second situation we say not applicable. The third situation you may find is that not recorded. The information exists, but it was not recorded. For instance, you go to a company, and because there was no internet, some transactions were not inputted. So it's not that the transactions are not there. It happens not just to have been taken note of. So we cannot just treat it as missing. We need to go and look for the data and record it, because that in reality, the information exists and the data collector or the person who was recording failed to record. A customer, another example, maybe you are trying to get phone number and you cannot find, the customer doesn't have a phone number. It doesn't mean that the person doesn't have, it's just that it wasn't collected. Yes, that it wasn't collected. Check what I have sent to you. So a customer phone number exists, but the employee did not record it, will be a good example. Now, another situation is that we may have what we call unknown. Yes. The situation applies, which I think we have already discussed that. The variable applies. It's not like this person is not applicable. It applies, but we don't know the answer. Yes. Somebody's nationality and you are not aware. You said the person's nationality is unknown. It's different from saying that the person's nationality is not applicable. So you have to understand these issues when you are trying to handle missing data. Sometimes the person deliberately doesn't provide that information. That might be the fifth situation. The data is hidden or deliberately removed from the view of maybe the data scientist or whoever. So if somebody says, ask for somebody's income and the person did not provide the income, what is your income? How much are you making? And the person's response was prefer not to say, then that situation is quite different. You need to understand. So the basic discussion or the point I'm making here is that it's not enough for us to treat missing data. It is much more important to know why that data is missing. And so missing data may have different, is to know why it's missing, because that informs you on what you should do. Another thing to take note when it comes to missing data is that different applications may present missing data in different ways. For instance, Python will often use this NaN, which is like null. They may use, in some cases, we may even use CNone. In some situations, you see null, like Power BI. In some cases, we see this, NA, unknown, and maybe some will have blank, and some will just have blank, empty space. Whatever situation you will encounter, these constitute elements of missing data, and you must be conscious of them when handling. So, if you see this, you should be aware that these are issues pertaining to missing data. Now, any questions so far, please?
I have none, sir.
Okay. So, now, how do we identify? If we go back to the concept, we say understanding. So we have tried to understand the concept of missing data now. The next thing is detecting missing values. How do you detect missing value? Detecting missing values. This is important for us. And so, the most common function that you will use is df dot is NA. This is the most common function. Is NA. This is the most common function that Pandas uses. And you can either use that or use def dot is null. Now, df dot is null. What happens is that all of them are trying to treat missing data, but they're highly likely to give you maybe slightly different ways of handling it. Is null, is NA. So if I run this now, what should I get? I've run this and I'm having. So now if you say it's NA, basically the response you get will be in form of what we call a Boolean. We've mentioned the concept of a Boolean before. And the idea here is that the responses will be in terms of yes or no. That's true or false. Wherever we have a missing value, the response will give you a true. So which means this first participant here, all this information was, but when it comes to deck, the person's answer was missing. So that's why it's true. It was true here, it's true here. And many of the aspects, they are not so. This code gives you the same result as this one. Let's say df dot is null. Again, we have exactly the same score. So these are two ways of getting the same results. Either you use NA or use is null. You'll get the same score. Now, at times when we give it this way and the data doesn't really present all its whole things or here, we know the data is much and they've just given us a subsection. Again, we cannot scroll down the entire data set to see. This dot points here means that most of the data is hidden. So there are so many rows that have been hidden here. So how do we actually know the exact? And that gives us to the next potential code, which is counting the missing. You may want to count missing values. You want to count missing values. And to do that, we have df dot is now dot sum. It will give you. Or if you still take df dot is now, it will also give you. So these are two ways of getting missing value count. And here, if you see from here, it means when you get to age, survive to not have missing data, at least as this data is concerned, every participant has a record. Same for passenger class. But when you get to age, we discover that there are 177 participants that their ages were not recorded or were missing. So that's how you get it. You may also want to get not only the absolute, you may want to count the percentage of missing. So you may want to count the percentage of missing data. And to do that, we'll now apply some of the concepts that we have already learned earlier by saying that, let's say we define a variable called missing underscore percent is the same as, we said df, right? df dot is na. We've seen this dot sum, dot sum. Let me see the sum. No. That let me just say the sum. Let's try something out with this code. Times, oh, what happened? Times 100. So if that is the case, let's print this and see what it gives us. Okay. That almost gave us, but did not give us. We have an issue why it did not give us. And the reason is that instead of taking the sum, let's take the mean and see what it will give us. Yeah, it has given us. Yes, you take the mean. This again tells us the percentage of missing or the average mean for the missing. So we may decide now to say they should print this missing dot, round it to 2. So they will now round out to 2 decimal places so that you can have a better view. Now, so are we okay?
Yes, sir.
Okay. Now, We have identified the overall row missing, but in some cases, we may want to check missing to specific column. You can just say def dot or we use square bracket and we are clicking on this dot is any. This is also for a specific column. You wanted to check for a specific column, as well as you want to check for all. You can do that. But we're looking at a specific column, for instance, ish. Now, the next thing we want to do is to find maybe the row. Find rows where each is available. So to do this, we basically say def where each instead of is not. It's an error. Def that ish that this is yeah. So can also use this concept. They will present to us those columns that are not missing. Wait. Let me use this one give us error. Not NA. Yeah, gives us the same thing. That these are only those that do not have missing data. Those that do not have missing data, not NA, which means not missing.
Says, you see that those, but I'm seeing under the date. I'm seeing some none there.
Some,
Under date, I see some missing data.
yes,
Oh, it's not missing.
yes, there's missing that data under there. Now, why the focus is on this, but this one, if the figure is not there, they will show NaN. But we're not checking on that. We're checking on give us records for the variable age where there's no missing data. So you will not find missing data in this, because we say not NA, which means not missing. Is that okay?
Okay, so I can see. This is only for age.
Yes, because only for age. That's why we factor in age. We have to index by age. And we are not indexing age alone. Age has other attributes. So the other
Okay, so I
attributes
see.
are also shown. But our interest here is for the variable age.
Okay.
Yes. Now, this one that your colleagues are not there. This is a very important topic. Oh. So why missingness matters? Why missingness matters? Now, imagine that you have a hospital data set. And so you have passengers, let's say the patient 1 has given an age to be 25 and the blood pressure to be 30, or maybe 120. You have another passenger who did not give the age and the blood pressure is 130. We have another one whose age is 70 and blood pressure is 180. Now, if we simply delete the second person because the person did not give us the blood pressure, nothing will happen particularly, but the issue with this kind of situation is that we lost data and lost vital information for decision making because age and blood pressure might be related. And so how to handle it becomes a vital or something of concern. Something of concern to the data analyst or to the data scientists. And so we cannot just delete because we're still missing data. It is important for us to understand because missing data sometimes introduces bias. If you don't handle it well, it will introduce bias. It means it might tend to give us results that are not a reflection of the population or a reflection of reality. And so we are we are called upon to study and understand. Now, there are three types of missingness. Three types of missingness. Let me put it here. Types of missingness. As data is concerned, we have what we call MKR, whose full meaning is missing completely at random. Missing completely at random. That's the most common. The data is missing. It's not attributed to a specific disease, just missing at random. And so this goes back to highlight what we've already discussed, like truly missing, not applicable, and the rest. So the missingness has no relationship. We say with missing completely at random, the missingness has no relationship with the observed or unobserved data. That means it really has nothing to do with the rest of the data. That is completely at random. Is that okay? That missing is not affecting any other variable. That's what we are saying. Yes. Maybe you had a computer that loses its ability to function may not directly affect the other computers. If the computer gets bad, it might not directly affect other computers. So if it's missing, it is missing at random because the other functionality of others may not depend on this particular computer. So that is missing completely at random. Now, another thing is missing at random. So there's a difference between missing completely at random. Where we say the missingness has no influence on the observed or unobserved data. What we have collected and we are not collected. It really has nothing to do. Now, the other aspect is missing at random. So missing at random, the probability that a value is missing depends on another observed variable. So when it is missing at random, it means there is a probability that the missing value depends on another observed variable. Take for instance, we ask for somebody, we've given the example of somebody's, whether you have a father, and the person says yes, and another person says no. So the person cannot provide the answer for the father. So that is missing, but it is not missing completely at random. It is missing at random because its missingness is influenced by another variable observed within the data set. So that is missing at random. Now, those are the first key aspects. Now, missing not at random. This I think some researchers call it missing by design. And most often we say missing not at random. Here we are looking at the probability of missingness is related to the missing value itself or unobserved information. We can ask your annual income. And people with very high annual income may be more likely to refuse to answer. Maybe they are afraid of tax and so on. So such a variable might be missing, but the missingness is not completely at random. It depends on another variable. So we have this situation, missing not at random. Missing not at random. So you say missing this. This one is abbreviated as MA, and this one is abbreviated as missing not at random. So this one is abbreviated as MECA. So these different scenarios are very, very important. So as a data scientist that we want to become, it is important for us to often understand whether the data we're dealing with is missing completely at random. Although that is the most common, missing ness requires is dependent on another variable that we have observed. And the last one is when we say that the data is missing and that missingness is not at random. Any question?
So is it possible to, like, just taking us back the two, we remove the missing data in each variable? Is it possible to remove all missing data in the whole, data in the whole data that we have? And all from all the variables.
Come again, please. I didn't quite follow.
I'm asking, is it possible to remove missing data from all the variables present? Like this one, we're able to remove missing data from the each variable.
Yes.
So can we also remove missing data from all the variables? Like we clean all the missing data from?
Yes, we can remove all. It all depends on, like we said part of the data cleaning process is identify the problem, understand the data, identify the problem, identify what is the quality assurance issues to be resolved and how to resolve them. What are the defensible? The word defensible there simply means that you should use scientifically proven approaches to clean that data. And so data cleaning has something to, we can always remove all, but you don't just remove, there is a way to remove. And in our next class, we'll see how that is handled. So we'll talk about keeping missing values, removing maybe the rows that are missing. We may remove the columns. We can fill in with a constant. We can fill in with a mean. We can fill in with median. We can fill in with mode. We can do group-based imputation, which we'll discuss that. And there are also many other methods that we can use to analyze. So, are we good?
Yes, sir.
Okay. If there's no question, since most persons are not there, at least I think we have gone for 1 hour, 30 minutes or so. Let's continue in our next class with now the practical part of dealing with missing data and the rest of the data cleaning. Now, it's important to maybe at this stage look for some data that has issues so that once we are working on this, you can be looking at it and trying with the data. Or maybe with time, when we are done with that, I will bring another data set that needs cleaning and analysis for us to go through and resolve that. So for now, if there's no question, I think that we'll continue our class on Saturday, 4:30. Are we good?
Yes, sir. It's okay. It's fine.
Okay, Saturday then.
Okay, sir. Thank you.
You're welcome.